Hello everybody, it's Goknath from the Crack with Gokulnath YouTube channel. So guys, today we're going to see kinetic energy of a rigid body which is rotating in a given axis. So what does it mean by this statement? So what is the definition of this statement? So guys, just we are going to find the kinetic energy of some rigid body which is rotating about a given axis or a particular line. That is what we are going to find. Just we are going to find the kinetic energy of that body which is in the rotational motion. So let me start the session, and it is going to be a short session guys. At the starting itself I am saying. So let me say one scenario like a rigid body. Some rigid body is rotating about a given axis or a particular line or a particular axis. It is rotating with an angular velocity of omega. That is what I am saying now. So some rigid body is rotating about a given axis with an angular velocity of omega. That's the scenario I am saying now. And I hope you guys would know what is angular velocity, right? Because you guys learned that the terminology angular velocity in your circular motion under angular variables. So you guys learned what is the angular velocity, angular acceleration, angular displacement, angular position. So many things you guys learned in your circular motion. So just and now I am saying a rigid body is rotating about a given axis with an angular velocity omega. Now if I ask you what is the kinetic energy of that body which is in the rotational motion, what many people will say is it is half mv square. Yes, indeed, that's the correct answer. So half mv square will be the kinetic energy of that body which is in the rotational motion, which is rotating at the angular speed of omega. So I will write the term here itself, which is the half mv square. This is correct only guys. Don't think that this half mv square is only true for a translational motion. That means a rectilinear motion. Not like that. It is also true for your rotational motion. So this half mv square, which is the kinetic energy, is also true for your rotational motion. So don't think that it is only true for your rectilinear motion. It also applies in your rotational motion. So this half mv square will be the kinetic energy of that rigid body which is rotating about a given axis with an angular speed omega. Now listen carefully guys. Now this is the kinetic energy I told. So I am going to just make some change in this terminology. Just I am going to make some change in this term to convert into other term. That's the first step which I am going to do. Just I am going to make some changes in this term to convert into another term so that you will be finding a new type of kinetic energy for an object which is in the rotational motion. So at the beginning itself I told, right, that body is rotating with the angular velocity omega. Now it is rotating with the angular velocity omega. I told that. Now in this term we are having v, right? We are having v, right? Can't I write this v as omega r? Correct na? Which is the angular velocity into the radius. So I can write this velocity which is the linear velocity. Guys, you know that, right? This v is nothing but your linear velocity. So this linear velocity can be written as angular velocity into radius. That's a basic terminology which you guys learned in your circular motion. Correct na? From this terminology only we are saying your omega is equal to v by r. From this only we are framing that your omega is equal to v by r. So your v can be written as omega r. This is a simple thing, a simple relationship you guys have learned in your circular motion. So this v can be written as omega into r, which is the linear velocity which is along the tangent, which is along the direction of motion, is equal to angular velocity into your radius. Correct na? So that you guys know already. So here just I am going to write this v as omega into r, because I know that rigid body is rotating with the angular velocity omega. So when I write this v as omega into r, what I will get is, I will get it as half into m into v square. We know that your v is nothing but your omega r. So when I write your v as omega r, you will get omega r whole square. As simple as that. As simple as that. That's the change I told. It's not a big deal guys. It's not such a big deal. Just the basic things which you guys already know. I'm not framing any new things. I'm not a god to frame any new things. I'm doing the things which I learned from many books like or NCRT, H.C. Verma. That's what I'm doing. I'm not telling any new things and all. So this V can be written as omega into R. That's the terminology which you guys know. That's a relationship, not terminology. You can say it as relationship itself because your physics should be defined everywhere. Okay, so this V can be written as omega into R, and that's why we are getting this term as half into m into omega r square, because this V is your omega r, so m into omega r square. That's all. Now, what is this term, guys? This term is nothing but half into m into omega square into r square, because omega r whole square is nothing but omega square into r square. That and I should not say. Because even a 600 student can say this. Omega r whole square will be nothing but omega square into r square. Simple things. These are simple things. So this can be written as half into m into omega square into r square. This will be your what? This will be your kinetic energy of that rigid body which is rotating about a given axis, where your m is mass, omega is angular velocity, and r is your radius. That's all. So half into m into omega square into r square will be your kinetic energy. But till now, not yet we completed the final relationship. Till now we did not complete the final relationship. Wait for some time. We did not yet completed the final relationship. I will say one thing, then only we are completely fulfilled the session. Okay, so I will say one thing. After that only you are going to find the complete fulfillment of the session and the complete fulfillment of the kinetic energy. So guys, we are having m into r square, right? As I know, this body is in the rotational motion. So if I am having m into r square, what is this m into r square? M into r square is nothing but your moment of inertia. Do you guys forget that? This mass into the radius square, which is nothing but m r square, is nothing but your moment of inertia of the system of particles. Do you guys forget that? Never forget that. Because at the beginning of the rotational motion itself, you guys learned what is moment of inertia. So this m into r square can be written as moment of inertia, which is I. So this term can also be written as half into m into r square is nothing but your I into omega square, and that's your new kinetic energy which I found just by this half mv square. Not I did any new things. That's the basic things which you guys already know. So this m into r square can be written as I, which is your moment of inertia, because you guys know that your mass into your radius square is nothing but a moment of inertia, which you learned in your first part of your rotational motion. So because you know now guys what is moment of inertia, and the moment of inertia of different particles like your continuous particles, your metal rod, your uniform rod, and even the circular ring, those things you guys learned. And the basic thing is m r square. M r square is a standard formula of your moment of inertia. So m r square is your moment of inertia, and we know that your moment of inertia is I. Correct na? Your moment of inertia is I, and that's why I am writing this m and r square as I. Just replacing them as i's because I know that formula. And this final term is your kinetic energy of that rigid body rotating about the given axis. That's all. That's all, guys. That's all about this session. And this will be your kinetic energy of that rigid body which is in the rotational motion, which is rotating about the given axis or a given line with an angular velocity of omega. That's all. So this is your rotational kinetic energy. So guys, this kinetic energy, right, I'm saying, right, the magnitude of kinetic energy. So the magnitude of kinetic energy is half into I into omega square in your rotational motion, where your I is moment of inertia and omega is angular velocity. This is your magnitude of kinetic energy, and this can also be written, this can also be called as rotational kinetic energy, because this kinetic energy is the magnitude of rotational motion only, right? This kinetic energy is the magnitude of rotational motion. Then of course I need to say it as rotational kinetic energy, because I should define everything on physics, right? I should define everything on physics, and that's why I'm saying like this. And this is your final rotational kinetic energy, and half into I into omega square will be your rotational kinetic energy. So that's all, guys. Thank you. Make education simple.